Guys, my name is Jay Lugo. I'm about the newest FAST team member for the Orlando area. I'm co-hosted with John LeDrew, and we have special guest Richard Mornington-Sanford joining us today. Thank you so much for being here with us. We understand you have a lot of choices when it comes to a Saturday night, so definitely like to thank everybody. We got people from all over the nation, and obviously Richard is already in the future in Malaysia, 12 hours ahead. It's morning for him, so very interesting. So, John, I'm gonna let you go ahead and take it away. You have the flight controls there. Take control of the meeting and go on.
My controls. Yes, my name's John LeDrew, founder. I'll just make this. Let me just get to my screens here, and we'll start our presentation straight up. Get right to it. So I'm going to share my screen, and here we are. If you guys can see this. I always wanted to find a way to put intentionally blank in a presentation, so just like a POH, so I was able to make that for this presentation. So Jay introduced himself. He's a CFI down in Central Florida for both Cadbury and Robinson. Very accomplished CFI. My name's John LeDrew, commercial pilot, SFAR for both 22 and 44. Always looking for ferry flight opportunities or low time commercial opportunities. I'm also the founder of the Helicopter Pilot Study Group on Discord. You guys see the link in the chat. Michael Triana, who's not here, he's part of the. He's kind of our right hand man, in the badass of the group. Army aviator, CW3 PIC, Air Mission Commander for the Army down in Texas. He's a bad dude, and we're glad he's part of our group too. He's not here today, but and then the star of the show is Richard Mornington-Sanford. Richard comes from a long history in aviation. 45 years working with Robinson, a good friend of Frank. Richard has worked closely in areas of engineering and flight safety and accident investigation, and Richard really is the star of the show here. What we're going to talk about is carburetor icing, and he wrote the book, Keep Your RPM in the Green. It addresses some of the things we're going to talk about today, and this is a really fun subject because there's a lot of technicality and things that we as pilots learn about but don't necessarily get to see some of the details, and Richard really has a lot of great stuff he's going to show on that. So the way this is going to work is I'm going to talk a little bit about some of the things that I learned in that G taught us in the Robinson Pilot Safety course regarding carburetor icing. We'll talk a little bit about the difference in the 22 and the 44, and then Richard can jump in at any time. So when we're looking at the when we see our CAT gauge in the 22 and the 44, we notice there's a difference. There's a placard on the 22 that says below 18 inches of manifold pressure. We want to ignore the gauge and apply full carb heat. And I was curious why that is. We got the opportunity to kind of learn from G on specifically why that is. And so on the right here, what you see is this is a carburetor. We have our air inlet. We have our venturi here. We have vaporized fuel. And on this side of the throttle body here, we have our CAT probe. But on this side of the throttle body, we can see what the carb temperature is. And this is the area where carb icing is most common. This is where the latent heat of vaporization happens when you convert a liquid into a gas. And so what happens is fuel comes out of the jet. It's forced to change from a liquid into a gas, vapor, and it absorbs a large amount of heat when it does that, and that comes from the induction air. And if there's moisture in that induction air, it's cooled by the vaporization, and it will freeze, causing ice to form around the throttle body and the intake. And this is what we commonly associate carb icing with, this section of the carburetor. But what happens is on the intake manifold side of the throttle body, Boyle's gas law comes into effect here. And what happens here, Boyle's gas law is simple. We know this because as gas increases its pressure, you increase its temperature. And we're aware of that as pilots because as we increase in altitude, we have less pressure and therefore temperature goes down, right? So Boyle's gas law applies here. And what happens is when the carb throttle is closed on a steep approach or In an auto, there's a large pressure drop across the throttle body butterfly. So on this side, we might have 29 inches of pressure, and on this side of the throttle body, we might have 12 inches of pressure. So there's a significant temperature and pressure drop. And so if there's any moisture in the air, it can condense and freeze on this side of the throttle gap, choking off fuel supply to the engine. And so the way that Lycoming has their carburetors set for the 22, the size of the 22 carburetor does not allow for this fuel or for the CAT probe to be on this side of the throttle body or of the butterfly. So what we see here is in the 44, we can put Lycoming can put the intake manifold or the CAT gauge in the intake manifold side, which gives you a much better and more accurate reading of where carb icing can happen. So that's really the big difference is where is the CAT gauge probe? And on the 44, because it's a bigger carburetor, it can be on the intake manifold side. And we don't have that placard on the 44 because it's measuring temperature on the intake manifold side, which is where on the 22 we can get into some of that icing below 18 inches. So this is just a quick carburetor icing probability chart that Robinson shares. I think pilots should see this and reference this more often than we do. I was kind of surprised to see this for the first time when I went to the safety group. But I chose a number of different locations scattered across the country: Tucson, Denver, Orlando, Bangor, Maine, Seattle, and Santa Ana. And when we see the temperature and the dew point, when we get that spread, that's where we're kind of measuring on this probability chart where icing is likely to occur. And in Seattle, it's clear, right? There's a clear high probability of serious icing because we only have a 2-point spread of 1, right? Everywhere else is kind of scattered. A place that's pretty clearly out of the range here is in Tucson, right, where we have a temperature of 24 and a dew point of -3, right? So it's quite a big spread, and that puts us out of the graph. And that's kind of a good chart. If you guys want a copy of that, I can certainly send it to you. But Richard, if there's I'm going to kind of pass the buck to you here. Okay, maybe kind of talk a little bit about, I don't know, let you take the presentation from here.
Okay, can we go back to your first slide?
Yes, sir.
Well, good morning or afternoon or evening, anybody. It's very early here in the morning. And it's a real pleasure to join you on this. I'm honored to be here as part of your FAA safety system over there. It's not often that a Brit's allowed into the into the US system. You still celebrate some victory or something you had over us some time ago, but we'll forget that for today. Right, okay, so yeah, quite correct, John. The upstream side of the butterfly valve, where the fuel is vaporized. It's vaporized for two reasons, quite rightly you said. It takes a lot of latent heat from the ambient temperature to atomize the fuel. And the second thing, of course, is that you've got the Venturi effect there. And later on, we're going to see a small sort of presentation. And you can see there are two Venturis in the carburetor. The main body itself is a Venturi, and then we have the master Venturi, of which the jet atomizes the fuel in. So that's correct, and unfortunately, that only gives us information about the upstream side of the carburetor, and you've mentioned that the R44 is in a different place, because quite honestly, the most dangerous point is actually downstream. So when you're reducing the power at any time, if you have allowed ice to occur inside the upstream side of the carburetor, then as soon as you lower the collective lever or reduce the power, then the closing of the butterfly valve is going to cause a venturi effect, and we get that drop in pressure on the other side of the butterfly valve. So quite right, the 22, we don't have a place to put the probe. On a 44, we did, and that's where it is. Actually, if you go on the 22, if you go into an auto rotation, you can actually see that the temperature on the upstream side of the butterfly valve actually increases. And our problem is downstream, the other side of the butterfly valve. And that's why Robinson had to put that caution in there below 18 inches of manifold pressure, ignore the gauge and apply full carb heat. Now, when you do that, you've just got to make sure that you apply carb heat well before you make any sort of change in your power, reduction in power. So yeah, and we're going to see the ice build up on the butterfly valve during this process later on. What I'd like to do, though, before we go too far, is how can we prevent it? I think that's one of the key things that we need to make sure we understand, and that is we can find out how bad or predict how bad our carb icing situation is going to be even before we actually get into the aircraft. So in other words, my weather, as John showed you the probability chart, if I look at the weather and just check my dew point temperature against my outside air temperature, that will tell me how dangerous or not it's going to be during flight. So that's the first thing. The second thing is before the first start of the day, I need to switch the battery on and check my carb air temperature gauge against my outside air temperature gauge. They're both, or should both, be reading the same. They're doing the same job. This can only be done prior to the first start. Once that engine's hot, then of course you're going to get a misreading, a higher reading on your carb air temperature gauge. So those are the two things I can start with. Now, during the actual, after engine start and prior to takeoff, what I'm going to do is, I know Robinson says that you should pull full carb heat during the warm-up. Don't, because you lose a lot of information if you do that. What you want to do is just start the engine normally and then do your carb heat check. So what I'm looking for is a drop in my RPM, my indicated RPM. And then if the drop remains, I don't have any ice in the carburetor. If the drop then changes and I get an increase in RPM, it means that I've had ice in the carburetor and the heat's just removed it. So the engine has become more efficient. So that's your key point. The last key point prior to takeoff is to make sure that you understand whether or not you have the possibility of carb icing in the carburetor. The second thing or the next thing to understand is that if I'm on wet concrete, or in the UK, we mainly work off grass. So there's usually dew on the grass in the morning. If I hover taxi over that grass or over wet concrete, I'm already building up ice inside the carburetor if I don't have enough heat applied to prevent it. So in that case, I would land, go through my carb heat check again prior to departure to make sure that I don't start the flight with any ice inside that carburetor. You need to make sure on your R22, my view is, I mean, I've purposely flown an R22 and R44, and I've purposely made the R22 ice up, the engine stop. And the only way I could stop that from happening in those conditions was actually apply about 15 degrees of indicated temperature on the carb heat temperature gauge on a known accurate gauge. Anything less than that, then there's a potential where my engine would stop. I get into an R44 in exactly the same conditions, and I can't get the R44 engine to stop, mainly due to the R44 being cowled. The engine is cowled, and so the carburetor gets some heat soak and benefit from that temperature. So make sure the carb heat temperature gauge is accurate prior to takeoff, and then keep it in flight. If you're in conditions where it's conducive to carb icing, then have about 15 degrees indicated during that flight. Back to you, John.
Awesome.
On there.
Great. Yep. Thanks. Yeah, that's really interesting. So do you find that the conditions that we learn for carb icing, these conditions are pretty accurate? If we find that we're in this between 27 and -4 degrees with high humidity, is that an accurate representation of where carb icing really happens?
Yeah, it is pretty accurate. The only thing you have to understand about the graph is the graph is designed and was built for a standard generic carburetor icing situation. The fundamental issue that you have flying a 22 and a 44 is that you're flying a D-rated engine.
Yes.
So therefore, the butterfly valve is in a completely different place compared to how they produce this chart.
Got it.
So you're more prone. 22 and 44, you're more prone. So you need to use a little bit of caution on this chart.
Copy. So do you want to talk to us about butterfly angle versus manifold pressure, or should we go through some of your slides here on actually seeing carburetor icing in action?
Well, do you want to show them carburetor icing first? And I'll go back to that chart.
Great.
I think it makes more sense that way around, yeah.
Great. Now, if I move this quickly, it almost looks like a video. It's kind of frame by frame, but I'm just going to kind of start pushing through it, Richard, and you stop me or tell me what was going on as we move it. How's that sound?
Yeah, that's fine. So to get this, we had a camera mounted on the airbox looking up at the fuel jet and the Venturi.
Great. So here's our carburetor body, our throttle plate, that's our butterfly, and here's our Venturi.
Yeah.
And this is where ice begins to form. And so this is what's really exciting for everybody here. I think you guys are going to love this. We actually get to see this happening. So that's a considerable amount of ice. And that's on the Venturi side, the downhills, the downwind side.
That's exactly right. Yeah. And that will stop. That will stop your engine if you allow that to happen. Yeah.
That's pretty substantial.
It is, yeah.
Now here on the intake manifold side, which is on the side of the 22 where the probe is not, but it is on the 44, we can watch this as well.
So you can clearly see there's very little area there that allows air to pass that snowball.
Yeah, those are pretty substantial.
Yeah. Now, even if you had a smaller amount of this ice on that carburetor butterfly valve, then if you don't clear that prior to reducing the power, then your engine will stop. I've had it stopped on me several times, so I can tell you from experience, it will stop on you.
Well, this is outstanding footage. Maybe you can explain a little bit how, but what Frank mentioned regarding why this is not as much of a concern in a fixed wing, direct driven airplane with a similar engine and a prop.
Yeah, well, there are two issues there that we need to look at. One is the question, why can I use partial carb heat in a helicopter and I can't do so in a fixed wing? And the answer is simply that in a helicopter, we have a gauge that allows you to see the temperature inside the carburetor. Whether it's in the right place or the wrong place is irrelevant. I can still see the temperature inside the carburetor. Airplanes generally do not have the gauge, so they are advised to, it's either fully hot or fully cold. That is the main reason why we can do both. Sorry, what was your other question, John?
Real quick, Richard, I got Jay over here on the chat. I got some questions. I'm going to go ahead and introduce Jay or acknowledge him. Jay Bunning from Bend, Oregon. Jay, if you can go ahead and unmute yourself and ask your question. There you go. Come on in.
Good morning, Richard. So I was asking if you recall when you recorded those videos, was that at idle RPM or flight RPM, and what kind of manifold pressure setting you or indicating manifold pressure you were seeing for that test?
Yeah, that's a good question. On that particular test, that was a bench test. Well, the initial part is the bench test where we had the camera in the airbox. Now, obviously, I did all this during flight. I did a complete test flight on this, but we couldn't put the camera on the downstream side, so we couldn't see that in flight. But the test bench was based on information I got during the flight test, and that was 18 inches of manifold pressure, if I remember correctly. So you can see, if you're a light pilot with half a tank of fuel, you're most probably cruising around 18 inches of manifold pressure. And if you don't use sufficient carb heat, that's what's going to happen to you.
And was that a Beta 2 engine?
That was a Beta.
So the problem is even worse than a Beta 2, like you said.
Absolutely, it is. Absolutely, as we're going to see on the graph shortly. Yeah.
Oh, thank you.
No, Jay. Thank you, sir.
Fascinating. I think we're going to have time here, so I'd certainly like to show your graph, and then maybe we can talk a little bit about reducing a power output when manifold pressure or when carburetor heat is added, and kind of red line and full throttle limits. But would you like to go through your graph now?
Yeah, let's go through the graph. Okay, so I produced this graph because I did a presentation to the CAA, UK CAA, many years ago. So we've got three colors on there: green, blue, and red. So the green is the R44. So that's the R44 at takeoff power. You have that green there. So that the angle, the butterfly valve angle is 60 degrees. Now, the interesting thing here is that if you look at or read Lycoming's information on carburetor icing, they say carburetor icing is negligible at takeoff power. And what they mean is takeoff power in a fixed wing where you're full throttle. So the butterfly valve is pretty much 90 degrees. So I would agree with them that in that condition, then carb icing is negligible. But of course, with us, we have a derated engine, and it is a real issue even at takeoff if you're in conditions that are conducive to carb icing. So on my R44 Astro Raven 1 carbureted R44 at takeoff power, so 225 brake horsepower, the angle is about 60 degrees. At MCP, you can see it's about 54 degrees. Okay, now the blue is a beta. So that first mark there that's your 131 brake horsepower. So that is what, 54, an angle of about 54 degrees. And at MCP, you're at 50 degrees. Now we get to the real issue, because most aircraft out there tend to be beta 2s. And so if I look at the first red dot, that is 131 brake horsepower at 50 degrees butterfly valve angle. And my MCP is about 47 degrees. Yeah, which is, if you're flying around and not using carb heat correctly, then in conditions that are conducive to carburetor icing, you are definitely going to get ice occurring in that carburetor. So the rule has to be that one has to assume that for whatever reason, I have got some ice in my carburetor. And therefore, when I want to make a reduction in my power, I want to pull full carb heat about 28 to 30 seconds prior to lowering that collective lever. That will make sure that you clear out the ice before you reduce the power. Now, one of the issues that we have is that if you have ice in the carburetor and you lower the lever and the engine starts to run rough, and then you pull full carb heat, because the ice is melting and going into the induction system, the engine is actually going to run rougher. So it feels and sounds like the wrong decision. So very often people will push the carb heat back into fully cold. And then unfortunately, that's the problem where your engine will eventually stop on you. So you have to understand that depending on what you have already allowed to build up in the carburetor itself, the worse it's going to run roughly before it smooths out after you've cleared out the ice.
Yeah, that's
so back to you, John.
Great.
All right, guys. I think we are pretty much at the time where the 1 hour, I guess, goes away.
Don't we have 20 minutes, Jay?
I thought so too, but for some reason my timer is reading 106.
Well, we got started a little early, I guess.
Yeah, we started at 25 after, so it's giving me the warnings. Just in case we drop out.
Okay.
It's
okay.
The warning that I was giving everybody. Obviously, if we can maybe take a few more topics, but just be careful, because if we do drop out, apologies to everybody. It's a teams meeting, and we're not upgraded yet. We're not making the budget yet. This is the right price. So, all right, guys, keep it going until we get knocked off, I guess.
Sounds good.
Okay, do you want me to go through this? So basically,
yeah.
The technical document that I produced many, many years ago, which the FAA are now kindly using, No Ice Thank You, was generated due to an accident over in Switzerland. And I took about 3 years assembling this document. And the fact is that if I apply carb heat, I change the density altitude of the engine. So therefore, what I've calculated on my manifold pressure chart no longer applies. Okay, in my document, I will tell you that given if I use full carb heat, then I can use X amount more inches of manifold pressure in order to achieve the same horsepower. You have to remember, it's the limit on this aircraft is horsepower, not necessarily placarded manifold pressure. Placarded manifold pressure only works and becomes a limit if actually those conditions are correct and don't change. Well, with carburetor icing, of course, they do change. So you must be aware that I can actually pull more power with carb heat applied than I have calculated on the graph, and I am not exceeding the limit of the engine or the aircraft drivetrain.
Right. So because we are derated, that means we can pull a little bit more, but we could get into a scenario where we're reaching full throttle.
Correct.
Yeah,
Yes,
and this
without doubt.
this is from Jay at Leading Edge. This is what they use it there for full throttle limits on in their helicopters, their 22s in Oregon at high DAs. This where normally
Okay,
we might.
red line is full throttle rule of thumb. Yeah, okay, so it's well on the safe side of things.
Mm-hmm.
By the looks of it.
Yeah, so using this graph on the left here, if we were pulling 1.5 inches more, then we would be at 22 and a half inches. And if we map that here, we're over with full carb heat, we're over our full throttle limit. So we can pull, but we're not going to get anything else out of it.
Yeah, that's true. One of the things, unfortunately, the tabulated form of the manifold pressure is not as good as the graph itself. Mm-hmm. Because yes, you can quite clearly see that the tabulated information doesn't really tell you too much, whereas I go to the graph, it clearly tells you that I can't get my 5-minute rating, 131 brake horsepower there. But I can, if I drop down 0.9 of an inch,
right.
Even then, I can't get my MCP. Yeah, it's not really, if you're using the red line that they have put on there as the rule of thumb, I'm not going to reach MCP until about, I'm not going to.
Yeah. No.
So I've only just seen that graph, so I'm not quite sure how they work that out. But the best thing to use on your pre-start card that sits inside the cockpit, you've got both the tabulated and the graph. Use the graph. The graph is far more accurate than the tabulated. On the 22, of course, the early 22s, then we also had the graph, but then they changed to the tabulated format.
Yeah, maybe you can talk a little bit about why they did that. My impression was G said that it was easier to read, but I don't think that that's necessarily it, but it does have less information. So do you have any?
Yeah, no, if I remember rightly, it was one of the engineers in an office somewhere thought that they'd change it to the tabulated form rather than the graph, and it was a mistake, really. It's not accurate at all. The problem is this is an FAA approved page.
Right.
So to get the graph back into the POH, it requires FAA approval and all the aggravation that goes with that. And that is why you will find it on the start card rather than in the POH, because the start card is not an FAA approved document.
Well, that's interesting. Jay, yeah. Do you want to maybe make a quick comment about your full throttle chart?
Yeah, sure. So we've had more of all the incidents we've had in the 5 years I've been helping run the flight school. I'd say the most serious ones have always been low RPM, where the aircraft was coming into an off airport and they were using carb heat on those shoulder months where it was pretty hot, but it was still within carb icing conditions, and they pulled the extra 1.5 inches, and even using Robinson's full throttle indication, they got low RPM. So I would say the full throttle indication is a bit like the out-of-ground effect hover charts. Don't bet your life on it. Don't bet your life on it. It's paper performance versus today's reality of the aircraft you're flying. So I took out all the R22s in the fleet from so basically carb icing conditions, very cold to kind of the high end of the temperature range of carb icing conditions, and set the aircraft up so that I had full carb applied and basically raised the collective till I got low RPM, and plotted a bunch of data across all of our R22s, and then took the most conservative line, and that's what that red line is. So we, as part of our pre-flight planning, pre-flight planning is one thing we talk about it, but when we're doing the run-up, when we get to the point before we bring the throttle up to flight, there's on our checklist, there's this version of the graph, and there's a little line there that says out of ground effect, hover performance, expected full throttle, and our manifold pressure limits for the day. So we make it part of our pre-takeoff checklist for the flight crew to discuss using that chart where they expect to experience full throttle based on the type of operations they're going to do that day. And that's why we put in there. Without a full throttle light, and our aircraft don't have that, if you're just pulling the collective up thinking you got that 1.5 inches, it's going to bite you.
Yeah. Okay, I agree with that. Let me just explain a little bit what we do in the UK, Jay, is that obviously we've got carb heat applied during the cruise, subject to the conditions that we're flying in. But what we tend to do is we will pull full carb heat prior to reducing the power from the engine. Okay, but at about 300 feet, we put the carb heat back into what we had as pre-selected. Okay, so that's not full carb heat. Or, depending on your conditions, you can put it back into fully cold. If your requirement is power at that point, which it sounds like it is, you can put it back into fully cold, because you have to understand that because you've been using full carb heat during the approach, the carburetor has heat soak. So if you put the carb heat back into fully cold, it isn't going to ice up on you. And anyway, the butterfly valve is now moving in the correct direction. So the chances of you getting carburetor icing in those conditions, I would say, are negligible. Your issue, as you quite rightly said, is power.
Low RPM. And Richard, we used to do, for a while we did that. That was the advice of, if in doubt, down and lock, short final, get yourself in there knowing exactly what you're dealing with, because, you've worked out your out of ground effect, because you've worked it out. Whereas if you're using carb heat, how much is it going to be reduced? But the trouble was, as someone pointed out, one of our management team said, the trouble is if we teach that technique and then our students go out to go work in Florida and they use that technique and they do get carb icing, it will all be back on us. And, being in the US, Richard, you know what litigation's like over here. So it is a tool that the instructors may use to get themselves out of something, but we just said, let's just assume that our out-of-ground effect is reduced by 2,000 feet, which is conservative. And, if you can't get in there, we're doing training in R22. We don't need to push the limits. So that's the way we went. But for a while it was down on lock to a standard procedure below 200 feet. And then you would then preheat again on the ground and then down on lock for the departure. But the US litigation, Richard.
Yeah, I don't disagree with that, because the rule should be that you teach them one procedure, and that procedure should cover everything so that they don't have to think, oh, am I in this condition? Am I here? Am I whatever? So I fully agree with that, Jay. One procedure covers everything. Your concern and our concern and every pilot flying's concern is to maintain that RPM.
Can you talk about a little bit about carb heat assist as you lower the collective? It adds carb heat. When we raise the collective, it manually reduces carburetor heat. And is that a solution for what you guys are essentially talking about, just to let the correlator and the carb heat assist do its mechanical correlation?
Right. The answer to that is no.
Okay.
And every year for tens of years, since Frank fitted that horrible piece of equipment, I've told him he should take it out because it doesn't work. The first thing is, when you fit something to an aircraft, it's supposed to reduce the pilot's workload. Actually, fitting that, every time I move that collective lever, I have to readjust the carb heat because the carb heat assist has just adjusted my applied heat. So that's the first thing. But the most important thing to understand is that the carb assist only applies carb heat as you lower the lever. Too late. Yeah, if you've allowed ice to occur in that carburetor, the engine's going to stop on you. So Frank and I used to do, every year, we used to have a fight over this, and we just agreed to disagree. He thought it was a really good thing. I thought it was actually dangerous for those people that actually do flying carburetor conditions. And of course, he's Californian. They only understand what goes on in California. And he fully admits, we had some people here in the UK, some very senior people in the UK, because I run the safety course here, and I run this section. And they went across to Robinson to find out whether my document that says I can use more than placarded in manifold pressure if I'm using carb heat. They didn't believe me. So they went across to Robinson. They sat down with Robinson and said, look, what does Robinson recommend? And they said, you need to go and talk to Dick Sanford in the UK. He knows all about carburetor icing. We know nothing because we live in California. So it's just, so it's rubbish. It's just a waste of weight. Don't use it as a manual control. I don't care. The other issue is that I pull some carb heat to keep the needle out of the yellow. I raise the collective lever, and what does it do? It puts the carb heat back in. So that tempts people to take their hand off the collective lever in the hover to readjust the carb heat. You must never take your hand off that collective lever in the hover. And because of these conversations I used to have with Frank, they were friendly sometimes, not all the time. Pete used to introduce me to his friends and anybody as this is Richard Mornington-Sanford. He comes across to Robinson every year and tells us how we should be designing our aircraft. And I said, well, absolutely, most probably that's correct, because as I say, you only know what goes on in California. You don't know what goes on in the rest of the world.
Actually,
so that's actually very interesting, Jay, what you were saying. I'm very interested in that.
Well, actually, what you're saying is very interesting, because I had a question. If this is the right time, it seems like it's a good segue here. If David Smith put you in charge of R22 product development team, what is the one thing you do? Would you say, hey, let's put automatic carb heat into this helicopter like the Capri G2? Or would you, do you think there's another important area? I do know that, Robinson are looking at the 22 again, and you may have already been asked this question, Richard.
Yeah, well, yeah. You're just asking me to give them another reason to not give me my visa. You saw the presentation where you saw the ice build up inside the carburetor. Yeah. Okay. Yeah. Well, I got involved with a company. This must be 25 years ago. working for another company that had drones, and they had little carbureted engines on that, and their engines kept stopping. So they asked this company whether they would design something, which they did, and it was very successful. So I said, well, okay, let me come and have a look at it. So I went and had a look at it. They showed me the test bed information, and they asked me what I thought I could do. I said, well, the best thing to do is you'll never get this issue certified in EASA. You won't have big enough pockets, and you won't live long enough to get anything certified in the EASA country. But the FAA might do it under an STC or something. So the best thing to do is go and talk to Frank. And so I said, but we're not going to do that until we can prove that what you show on the test bed actually happens in flight. So they bought an R22, and we fitted the camera in the airbag. This is, I don't know, statutes of limitation, but we modified the carburetor as they had with these drones, and we put all sorts of instrumentation in there, and I did test flying in it. And I had a little screen. I could see inside the carburetor, and I could see the ice building up and everything. And then I could press a button, and the ice would just disappear, instantly disappear. We had a heated butterfly valve. So we took all that information from my air test, and we laid it over the top of the information we'd gathered from the test bed. And it was identical. Absolutely identical. So I phoned Frank up and said, Frank, I know you won't fit an injected engine into the R22 because keep it simple, keep it light, keep it economical. An injection engine is against all those things. So I understand that. But how about I come across and give you a presentation on something that is about the size of a matchbox and weighs pretty much nothing, it's negligible. And he said, I'm interested, Dick. So off I go, and I do a presentation to Frank Robinson, Pete Rydell, Dale, and a few other people. And at the end of it, Frank said, this is fantastic. He said, we'll do this. And he gave me Dale Tuft. Unfortunately, he died a while ago as well. And so they started running with it, and I was ever so excited. And then Dale phoned me up and said, Dick, I'm sorry, we've got to drop your modification because the R66 is behind in certification. So we're not working on anything that doesn't have R66 on the drawing. So once the R66 was certified and going well, it was Kurt and Pete Rydell phoned me up and said, Dick, about this butterfly valve modification. I said, yes. He said, well, you brought a carburetor over, didn't you? And I said, yes, I did. He said, where is it? I said, well, it's in Dale's office somewhere. So they found it. And then they put Hannah, a female engineer at Robinson, on the project. But hey, lo and behold, along came the R88. So that's now been shelved. However, my understanding is that Lycoming were very, very interested. Correction, not Lycoming. The manufacturer of the carburetor were very, very interested in it, and they wanted to take the project forward, which they did. They went back to Lycoming. The Lycoming lawyers said no. So the Lycoming lawyers basically stopped this system. I don't know how many people we've lost in those 25 years due to carburetor icing that are completely and utterly unnecessary. Yeah, so what would I do at Robinson? Well, there are some major changes to the R22 in the pipeline. I can't tell you what they are, but it's going to transform the R22. But if that doesn't happen, then if I was in charge, or if I had the ear of David Smith, which I do to a point, then I would progress this heated butterfly valve to remove this carb icing. So, because it's automatic, the pilot doesn't have to do anything. We don't remove the current system, because under FAA regulations, that's the method that they have for removing ice from a carburetor. So, yeah, the answer is I know there's a big change, and I would fit the heated butterfly valve tomorrow if I could.
I'm guessing the G2 is using that with the auto carb heat or something similar to that point. And until, I guess, I mean, I love the 22, but I think if I had the choice between a 22 and a G2, I would climb in the G2, no questions asked. Now, when it comes to the R44, then that's a different story. Until Gimbal can make the G5 that they are announced, then it's going to be a waiting game. But they do make remarkable machines. I challenge anybody that hasn't flown Gimbal yet to go and give it a shot.
Yeah, well, that's hence they're revamping the R22. They came up with a cadet. The cadet was a knee-jerk reaction to the gimbal and was wrong in my view. But they do sell a lot of them to the tuna fishing boat people, which is useful. But I think that if there's one component they're still having a few issues with for this new version of the R22, if they resolve that, which they think that they probably will, then watch this space.
So I need to buy you a few drinks, Richard, to loosen your lips on this. I'm going to guess though, I'm going to guess it's an engine, because then that would solve the problem, and probably not a Lycoming engine. What's his reaction? Zoom in, everyone. See his reaction there.
They were a little loose-lipped at the safety course too. I think I can say what I heard. You guys think I can say what I heard?
Is it being recorded anymore?
If you've heard it on the safety course, yeah. I mean, I think quite some time ago, David Smith actually let it slip. But we have short memories.
Yeah, it has something to do with snowmobile engines.
Yeah, well, I'll put on my best poker face, Jay. Okay. And,
I'm excited to see that happen, come to fruition. And the reality is, our fleet in the training world is generally older. It's 90s, early 2000s helicopters. So, I'm looking forward to the day when I can fly one of these newer Robinsons. And that was one of my points of feedback points after the safety courses. We're flying serial number 4, of the 44, right? I mean, the thing, it's like brand new. They do an outstanding job maintaining it, but I think a lot of pilots, unless you're at a school that is invested in newer Robinsons, a lot of pilots coming up through the training ranks are flying older Robinsons with steam gauges and in 430s. It'd be nice to be able to get behind some glass or to see to fly some of these kind of tighter, newer ships. And as exciting as that 22 is, I don't know when or how I'm going to be able to get in the cockpit of one of those, but I'm really looking forward to it. Should it happen?
Yeah, the program is a long way down the road. Mm-hmm. I say there's this single component that they're having slightly issues with the FAA, I think, rather than actual design issues. Mm. For serial number 4 R44, that's owned by Bob, yes.
I thought it was owned by Robinson, but yeah, I mean it was serial number 4, or it could be 7, but I'm pretty sure it was 4.
Yeah. Four. I think used to belong to Robinson. They had it on the flying school. I say flying school on the safety course flying element. But no, I'm sure that went to Bob in the end. But it doesn't matter. It's still flying, and it looks brand new. Yeah. And that's the wonderful thing about their inspections, their 2,200-hour inspection. That aircraft goes onto the production line. It comes, I would defy anybody to have a new R22 and a 2,200-hour completed R22 from Robinson side by side and tell me which one is the newer one. They are fantastic.
And that's a good, one of the things I fly every now and again is a 1976 Bell 206. Well, of course, that thing's never been rebuilt, and it looks like a 1976. And I'm wondering, I'm sure they do a great job on the maintenance, but I do wonder, as far as metal fatigue and things go, how long do we know these things can last for? I mean,
Well, yeah.
people run up to 22s, but
Bell have always been pretty good at that. If you look at the A with the old C18 engine, what was that, 1966 or something, and look at a Long Ranger 3, it's still certified under the 1966 FAA certification rate, and it's a completely different aircraft. Yeah.
407, yeah, 407 as well.
Yeah, the 407, and you see, Frank had that choice when it came to the R66. And that is, he could have called it an R44 turbine. And it would have been certified just like Bell. But he didn't. He said, no, this is a new aircraft and I want it to comply with all the latest regulations, and which was a fabulous, brave decision to make. I think it was the right decision, but of course, in Europe, it gave us all sorts of headaches. EASA didn't want it in Europe because of the EC120 line. Bell put the white flag up and said, "Okay, we can't compete," which was a shame, really. But he did the right thing. It's an R66. As it is.
It's hard to imagine things moving slower than the FAA, but EASA apparently is the winner there.
Oh, by a country mile. I mean, if you think it's slow under the FAA, I mean, I think it's most probably a speed that's less than a glacier movement.
Oh, but what about CAA versus EASA? Because, once Britain broke off from Europe, you have your own aviation authority, right? Is that right?
Yeah, absolutely right. So the only difference that's made is, for me in particular, because I run both EASA courses and CAA approved courses, which means I have two lots of certification costs. But the CAA generally follow EASA. It would be pointless to do anything else. So it's just caused a nightmare and cost, really. Anything else? They're just as slow. But no, it's exciting time. David Smith has, he's just made such a difference at Robinson. New blood, ex-MIT. He's got an amazing team behind him now. In every department. All these new things that you see. Part of that is Robin. All these new versions of the R44 and the 66, and I think it's absolutely spectacular. And I think, thankfully, I haven't upset them sufficiently for them to say you're no longer required, Dick. So I think earlier this year, I said to David, look, I'd quite like to make it 50 years with Robinson. And he said, as far as he's concerned, that's no issue at all. So let's see, I'll still be around a bit longer yet. And I'm still writing articles and things like that. I've got another book actually in the making. All about some of the stories and things that we used to get up to. But that won't be published until after our death.
Oh, no kidding. All right.
Okay. It's the secrets book. Okay, that's awesome.
Well, no, it's not the Robinson secret book. It's just some of the things that we could do in those days before the iPhone. Now, everybody's got a camera now.
Yeah.
So as soon as you do anything, you're on film instantly, which in a way is very, very good because we can see some of the accidents from both outside and inside the aircraft.
Right.
And of course, the new kit, audio and camera, that they fit as standard in the R22s and 44s and 66s is producing some amazing information. I mean, we always knew it wasn't a product problem, but now we can prove it's not a product problem.
Oh, yeah.
It also produces some pretty powerful visuals for students and instructors and pilots to, you know, what can really happen. It's not just a couple of lines on the NTSB report. We can see it. Like that one that happened in Australia, they did a fantastic job with their, as Australia always does with their accident investigations. Their that Hawke's Bay one, the R66 that went inverted as the guy's eating his chicken sandwich. That was extremely powerful.
Yeah, but there's actually a very good. I mean, what we're trying to do, and I've been trying to do it for I don't know, more years than I care to think, like tens of, is that in the days of crispy bacon and long hot summers, when you were covering emergency, and Jay, that'd be interesting to know what you say about this, but in those days, we would ask the student what their reaction would be to a light or an emergency or a caution or something like that. And all they had to do was verbally communicate what they thought they had to do. And it was either right or wrong. And actually, on the safety course, they used to do exactly the same thing. And I said, well, look, have you ever asked your student to tell you verbally and then asked them to tell them to actually do it? Because they are two completely different things. You'll find that when they do it, they go into auto rotation, they come out of auto rotation, they have no idea. So what we want instructors to stop doing is asking for an audible response from the student. You get the student. One is that you demonstrate to the student what they should do to fly the aircraft to a safe point on the ground. And then after that, all the training, when you ask for a procedure, emergency procedure, or caution light, or whatever, they should be doing exactly that. And that way, they have something to call on. It's a bit like, if I don't teach somebody to go around on a bad approach, then they're never going to do it when they're getting into difficulty on an approach. You've got to give them something that they have knowledge of as a means to escape from a situation.
I completely agree.
I don't know what you do, Jay, but that's...
No, I mean, I do a lot of internal training with our instructors, and I was doing a recurrent flight last week in an R22 with one of our instructors. I gave him I think it was a clutch light EP, and it was, hey, do it. And he looked at me and I said, do it. So he pulled the circuit breaker. And he said, well, where should I go? I said, do it. It's happening. Do it. So, and he said, is it okay to land down there? I said, well, what would you do? Yeah. So I said, don't put skids down, because I don't know if that's private property or not. It's in the East Practice where it's public land, but we don't, some of it. But I could see the uncomfortable feeling of doing this for the person. And afterwards we sort of talked about it, and I said how important, and we talked about how important it is for students to, as you said, it's two parts to it, I think. One is, it's making you think differently than just flipping a memory aid card. They're like, okay, what is this, EV? This is what it is. And you're engaging the idea of reality of what would I actually do, what's acceptable, what would I consider, how soon would I put the aircraft down? Actually, it was a main rotor chip light. So I said to him, are you really going to climb away from this? You really want to put pressure back on that gearbox and go around on this, because it wasn't perfect, this big long road, and it wasn't where he wanted to go. I said, if you don't put this scenario to a student, they will never think about it till it's too late. And the thing is, EPs don't care how many people are on board. It will happen whether there's a solo flight or a construction flight. Yeah. But I think the other thing to it is just the memory of it. Is if you're doing flip cards, you're using a different part of your brain than actually experiencing what would you do, and it creates a much deeper memory as well. So it's going to help you to remember what to do when it really happens, not just the experience of how you might think about it, but what are you really going to do? Is your mind going to go blank, or is it going to recall the same situation you did 3 months ago with your instructor, and it clicks in, and you follow your training? And that's what we hope everyone does when the shit hits the fan for real.
Yeah. Well, it's a bit like hovering, isn't it? You've got to allow them to lose control and learn how to regain control. Because technically, you could teach somebody to hover. If you come onto the controls as soon as it moves away from where you want it to be, you could actually technically teach somebody to hover the helicopter. And when they get in it by themselves for the first time, and it goes beyond that situation, they have no method or means of regaining control. I mean, there's another Australian report that's come out recently that actually it's a R44 Clipper, and he had a perceived engine problem. And this is another one of my hobby horses about not teaching enough manual throttle manipulation for a student. That when that person passes out and is given his license to learn, his PPL or whatever you like to call it, they should be able to fly that aircraft comfortably without the governor. And this R44 Clipper got into an issue, an engine power loss, and he produced most probably the perfect emergency procedure technique. I mean, it's, reading it, it's textbook stuff. And God, if we taught everybody to that same level of ability when it comes to governor off or just general emergency procedures, we would save a lot of aircraft and a lot of people.
As a student, relatively recently with some newer instructors, some of them only 220 hours, relatively low hour time instructors. Those are some of the things that I certainly would have benefited from that I didn't receive, and I only through my own persistence and dedication to trying to get good at emergency procedures, in practicing them in my head, not necessarily actually in the act of doing them. I was able, at least because of my diligence, to be able to kind of pull it off in my check ride, my commercial check ride, where the DPE asked me, he's like, "Okay, you have an oil light. What do you do?" And I was walking him through it, and he goes, "Do it," and it was great. I lowered the collective. I found a spot. We kind of went to set the helicopter down. And he goes, "Okay, engine failure, right?" on the way in. So it was, I'd kind of, but I hadn't practiced that, and I would have benefited from it dramatically had I had some instructors with the forethought of teaching that.
I think part of it.
Sorry.
No, go ahead, Richard.
No, I mean it's very simple, really. That you just have to get the student and the pilot. I don't care how many hours they have. Is that usually the safest place is right below you on the ground. So you fly the aircraft safely to a point on the ground, and that puts you in a position where it's better to be on the ground wishing you were in the air rather than in the air wishing you were on the ground. So these things have to be dealt with early. So like trigger points for deteriorating weather, all those good things that unfortunately I just don't see them being taught. I mean, I go around the world quite a bit, and it's just generally these things are not taught, which helps, unfortunately, to increase the accident rates that we're having.
I'm kind of surprised by that too, frankly, because it doesn't seem like it's that hard to find this information that a lot of people agree on, right? I mean, we're being proactive and talking about it in this group, and people are going to these seminars to listen and learn about being better instructors. But it just seems like this information is readily available and these techniques are available, but still hearing that they're not commonly practiced is a bit of a surprise.
Yeah, well, I think one of the reasons that in sort of manual throttle manipulation skill, loss of, if you like, is the fact that it's not being taught. So you've got instructors out there who are frightened witless if the governor failed. They in themselves wouldn't know what to do, because there's that paragraph in the pilot's operating handbook that says the governor has to be switched on. And so they use this as a reason for them not to teach governor off training.
Mm-hmm.
But of course, Bloggs, the student, needs to say, well, okay, sir, can you carry on reading what that paragraph actually says? And the paragraph says, except for emergency procedure training. And if governor off and low RPM and all those other good things are not emergency procedure training, then I don't know what is.
And I think, I think some of those, I think a lot of instructors might be afraid of it, like you said, weren't really taught it well, potentially. And big ups to Rogue Aviation out in California in Long Beach, yeah. I flew with them, and we spent quite a bit of time getting me comfortable with flying the helicopter without the governor. And the correlator does an outstanding job. And I think people don't recognize that and don't realize the correlation between the correlator and the governor and how well it works.
Yeah. Well, in the days of crispy bacon and long hot summers, when I was, of course, I've retired some time from flying, but when I was doing the flight safety course element in the UK, one is we'd do the whole hour and a half or whatever it was without the governor, teaching them to take offload, showing them how good the correlator is. And I could take them from an 80-knot cruise into a 65-knot full auto rotation, recover and go back to an 80-knot cruise and not touch the throttle. The correlator is that good. And then I would, either on the approach or on the downwind, we would check everything, and then I would pull the two circuit breakers, the rotor and engine RPM circuit breakers. So I've got no governor, and I've got no physical indication in the cockpit, and just tell them just to fly the aircraft to a normal approach. And in the hover, I put the circuit breakers back in, and there the RPM was exactly where it was when we left it. And then again, once they got comfortable with that, what I would do is actually on final, I would just squeeze the throttle closed until the horn and light came on, and then get them just to put the horn and light out. Not to open the throttle much, but just open it sufficiently to extinguish the light and the horn, and then carry on with the approach. And after that safety course, they had more than enough faith in that correlator system that they didn't really care whether they had the governor on or off. And that's where we need to get to. We need to get that level of confidence in that correlator, because it worked for us in the old days. We never had a governor. My view is the governor should not be used during training because it's an aid, and it should be switched on at the end of the training, and then shown as an aid and how good it is.
Yeah, certainly something I will consider when I'm an instructor. And Robinson safety course, they talk a lot about and the governor and the correlator, and that's a 4-hour conversation. So
oh gosh, yeah, I mean, you can go on a long time with that. But we've got to get to the stage where the pilot, the student who becomes the pilot, is comfortable with flying the aircraft without the governor to a safe point on the ground. That's where we need to be, and it's not difficult.
That's the first I had heard.
I was.
Go ahead.
Sorry, John.
Oh, well, that was the first time I had experienced and heard of a auto rotation recovery without rolling on throttle and using the correlator to recover RPM. And when I first heard that and when I first experienced it, I was like, what? You know, it had never come up in 180 hours or whatever of flying, 190 hours of flying. And I was just like, what is this? And now, since then, that's how I recover auto rotations because it's so much more logical. And don't worry.
Great. See, yeah, I mean, every day is a school day.
Yeah.
I mean, it's just so. But if assume we've got a bit of time, and you don't mind me going on. When I never wanted to be a flight instructor. You know, I was doing test flying. I didn't have enough time to add another string to my bow. I really wasn't interested, but I was pretty much bullied into doing it. So we get to the point on this course, and I was lucky enough to have the chief principal of Bristow's flying school, who was just retiring, to do my instructor's course. And it was a Friday morning, and we were doing, we were doing engine off to the ground. And I could, at that time, I could talk a nice engine off to the ground. I could fly a nice engine off to the ground, but I couldn't do both because I'm a boy. I can't multitask. And so I put this thing down just before, and I said to Stan, Stan, I've had enough. I don't want to be a flight instructor, so why am I putting myself through all this and you through all this rubbish? He said, oh, no, Dick. He said, no, we never stop on a bad point. So let's go and have a cup of coffee. And then what we'll do after lunch is we'll go up and do the upper air work. You can be the student and I'll be the instructor on the entry into auto rotation, because you're good at that. That's not a problem. I said, yeah, okay, well, if you want to do what you want to do, then that's fine, I'll sit there. But I wasn't interested. I'd lost interest at that point. And so off we went, and Stan we were at 2,000 feet AGL, and Stan was talking about entering auto rotation. So he goes, high area security engine, T's and P's, warning lights are out, look out below, full carb heat, lower the lever, close the throttle, blah, 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 blah. I was not listening to what Stan was saying. I was thinking, do I go to the pub tonight? Do I? And Stan was yakking away in my ear about, loading the disc in a turn and all that, keeping the airspeed. And I was just looking out with some cows down there, and there's a, nice hedge over there. And I looked down and I looked at the instrument console, and I saw that the low engine oil pressure warning light was on, and the alternator caution light was on. Mm-hmm. And I thought, well, that's strange. If those two are on, the engine must have stopped. So I look up at the dual tachometer, and sure enough, the engine gauge isn't where it should be. So I said to Stan, hey, Stan. He said, what? He said, I think the engine stopped. He says, oh, has it? I said, yes, look, because these two lights are on, and I don't have any engine indication. He said, oh, have you ever started one of these things in the air before? And I said, no. He said, well, you better have a go.
Wow.
Which we did. But you could say, he was as blind as a bat and deaf as a post in those days. And so we would have got to a point where we were recovered, and we would have got low RPM because we hadn't got an engine. So the first rule is, off airfield, of course, you must always have somewhere to go should something like that happen. And the second thing is that really, once you're in auto rotation, the instructor should actually monitor the engine RPM and the rest of the lights, and not just assume that the engine's going to be there. Particularly in a Raven 2, because in a Raven 2, you close that throttle too quickly at any sort of altitude, then you'll get a rich cut. But so the engine can stop, and of course, because he put right pedal in during the entry, we didn't notice it. There's no audible difference in sound at all.
That happened recently in where was that? Have you seen that video with the young instructor and the engine quits? Raven 2, they kind of balled it up. They walked away from it, but
into that rough field.
Yeah.
Yeah,
that one. I think, and honestly, he did a good job, like making it survivable. But for a few seconds there, I don't think he even realized that his engine was off.
No. I mean, if you look at the AIB, our accident reports, a few years ago, the number of times we had an instructor teaching auto rotations to a full touchdown, to a power recovery, and got to the point where they recovered the engine. It wasn't there, so they ended up doing a full touchdown auto because they hadn't monitored the rest of the instrumentation. They tend to concentrate on airspeed and RPM and rate of descent.
That's true.
Yeah. Jay, you're very quiet.
I'm taking it all in. But obviously, if anybody does have it, it feels like we've been kind of running it between the four of us. But if anybody has any questions for Richard, the remaining one of us, feel free. We can unmute you and you can ask away.
I recognize Clay. Clay's one of our leading edge graduates. He came through the program. One of our instructors, or students and instructors. Clay, you must have a question.
Is he on there?
Putting him on the spot.
Yeah. Right.
The boss is like, hey, speak up, Clay.
How does engine failure go?
Yeah, that's good.
Let's see what this spotlight for everyone.
Oh man.
He's probably doing something. He's just gonna get the.
He's watching.
There.
He was most probably asleep.
He goes at work, but yes, I do have a question.
Sometimes
he says he's at work, but he does have a question. Okay, let's see. Put it in the chat if you can't speak.
Yeah.
That's good. I like that he's.
That always works.
He's moved on from leading edge. He's now SIC and Skycrane, but
oh man,
nice.
I think he still comes back and does a few stage checks for us. But
I'd like to talk to Clay because I'd like to be SIC on a Type 1 fire ship. Also,
he's the guy to speak to.
That's one of my goals here. I bet that thing's fun to fly.
If we go back, John, to one of your slides where you were talking about the drop in temperature due to the vaporization and the Venturi effect. That drop is somewhere between plus 20 to 30 degrees in that area, which is quite considerable.
Here.
Yeah, that drop in temperature on the upstream side of the butterfly valve, where the CAT is for the R22. That drop in temperature there, say due to the Venturi and atomizing the fuel, is 20 to 30 degrees change in the incoming air temperature.
Yeah, that's
reduction.
That's substantial.
Yeah, it is. Yeah, absolutely. Yeah. So any moisture you have there is, and of course we haven't talked about the lock on the carb heat assist, and of course that's there because there are atmospheric conditions, which I think generally is accepted. Sort of, if you get to -6, then degree C. You have this funny Fahrenheit thing. How did you end up using Fahrenheit? I have no idea.
I don't know.
No,
has nothing to do with our relationship.
-6 degrees C, any moisture in the air is already an ice crystal. So you don't want the carb heat assist melting it and then and it refreezing on your carburetor. So you'd lock it off. That's the reason for the lock. Yeah.
Well, this is fascinating footage right here of this icing.
Yeah. And I say it did the same in flight.
Yeah.
But we set that at MCP, and sometimes they're less than that depending on the person flying, the weight, the all-up weight of the aircraft.
Yeah.
Richard, I'm intrigued about that testing. Were you doing circuits near a surface to do a fall down, or were you in a hover, or how did you actually set up I did everything. So I did a full flight program in the hover, over wet grass, over wet tarmac. It wasn't tarmac, sorry, it's concrete. In the climb, in the cruise, in descent. It was a full
unofficial flight test of an unofficial modification. So it was experimental, but it proved just how good this is. And we had to prove that. I'm quite happy starting engines in flight. I don't have a problem with them. But obviously I make sure that I'm not below a certain height, so that I've got the time to restart it. I might be crazy, but I'm not that crazy.
All right, guys, let me do, so I just got another warning from this thing, 45 minutes or what have you, so we might get knocked off. So real quick, let me do some shameless self-promotion, because I always forget to do this. But I just did a podcast with a young man. He's a fixed wing guy. That's his channel, All Terrain Animals. Me and him kind of discussed the differences. You guys are kind of welcome to tune into that. And then having said that, let me see, I stopped sharing. I'm going to go back here. I wanted to maybe discuss maybe our future guests. And I was thinking obviously we'll have Richard back again because he's got an awesome governor. We kind of got into the governor as a side tangent, but I'd love to do a presentation on that. But I was thinking maybe next if we could maybe reach out to Pete Gillies if anybody has a contact with him, that'd be an awesome person to have as a special guest for the next one. But if anybody has any ideas for what we could do next, that'd be awesome for next month. So we could either strategize now or do them, as time progresses. But
Richard, let's use your contacts.
I know Pete Gillis really well. I know.
Oh,
Pete,
yeah. So
we used to talk a lot.
So you could do the intro and help us make that happen.
And because funny enough, he was doing that in America, and I'd been drumming that in the UK just separately. And then he heard. I think it was I can't remember, it was a German or something, had attended my flight safety course, and he had been taught by Gillis, and he sent an email to him, and he said, yeah, absolutely, that's the right thing to do. So I got an old email, I'll send it to you, so if you want to contact him.
Yes.
Yeah, that's great, but he calls it cycling back, I think.
Yes.
I call it, the flare.
Yeah.
It's exactly the same thing. On entering auto rotation, you use some airspeed energy because you've got lots of that, and you don't have a lot of energy in your rotor system. And I can't use potential energy if I'm a brick. So again, primary thing is to maintain the RPM. During that initial stage. And the other thing that I'm not sure whether he talked about, but when you're flaring, of course, on an auto rotation, you've got to change the induced flow from down through the disc, so up through the disc. So if I flare, one is I'm transferring airspeed energy kinetic to my rotor. Second is I'm automatically changing the airflow up through the disc, which reduces the angle that you have to go through to get into established auto rotation. Yeah, so Peter Gillis would be a great person to have.
Yeah. Jay just did, and to plug Jay up with his auto rotation video that he put out. He discussed that. And yesterday, Jay, I was doing these approaches with a Cabri. And to your point, how you said, hey, go ahead and lower the collective and don't cycling back to see what happens. And yes, I was showing my student how the nose dropped. So it's like, it feels weird, right? So you have to apply that aft cycling to get you in the right conditions. So it's always interesting training people with this initial primary training where you got to really, really go back to basics. And so that was in my mind. I said, let me show. This is a great time to show them what happens if I don't apply aft cyclic. And sure enough, I waited 2-3 seconds and there we were looking at the ground.
Yeah, I'm glad that works in the Capri too. Yeah.
Yes.
Yeah. Well, that's an aerodynamic stuff through the
Yeah.
rotor. But yeah, I mean, talking about these videos online, I would say 99.9 of them are not particularly good because there are elements of incorrect technique, incorrect information, incorrect phraseology, all those sort of things. And so my view is always when I'm talking, people always say, "Oh, well, I want to make a video or whatever." I say, "Well, look, you know, go ahead. It's helpful, but be mindful that you cover these things and this lack of correct terminology during auto rotation, or the fact that the instructor's going blah 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 in this guy's ear who's trying to fly the aircraft. You have to understand that when these guys are flying, or women, of course, they're stressed. So the first thing that leaves you when you're under stress is your hearing. So you can be talking as much as you like, and they're not hearing you. So yeah, go ahead with these videos, but make sure they're reasonably accurate. Otherwise, you're introducing negative training into the industry, because a lot of people prefer to watch something rather than listen to something or read something. Yeah.
To add a point to that, Richard, the FAA is actually putting some CFI DPE forums, and I went to one a few months back, and surprisingly enough, they were talking about the whole RPM airspeed outside, right? The whole song that a lot of us sing when we're doing an auto rotation. And the DPEs actually said, yeah, it's getting, one time it's fine to let us know that you are monitoring. But the fact that they're saying it and half the time they're not doing it, it gets a little bit annoying because, yes, you're saying it, but you're not applying any of the actions that you're doing. But yeah, I try to stay away. I let Jay do those training videos.
Yeah.
His are pretty awesome. I think most of us younger pilots kind of grew up watching him at least 10, 15 years ago.
Younger pilots, it's all the gray hair. I hear what you're saying.
Yeah.
I hear you.
Well, that's those his videos are a bit bigger part of his series, right? Which is common student errors, and those are there's like a 3-parter, right? And you were breaking those up into sections for videos, right? So yeah,
I'd say they're uncommon. They're dangerous. They're not the common ones. They're the more dangerous ones, because they aren't that common. But if they happen, they're going to ruin your day for sure. Yeah. Real quick, Jay, you said about the RPM airspeed outside. I think there's 2 things real quick to say about that. One is, I think you have to, if you're going to do that, I would say double up the outside. So either speak with a real southern accent on the look outside and hold out there, so you put more emphasis on there, or say it twice or something. But I think the way we kind of do it at our school is, if it's an initial tool to have a brand new student to guide their eyes and keep them moving. Once they got the basics of that, as long as they're not fixating, we don't ask anyone to keep going through on that. But one thing I would say is, as they do that initial, whatever your verbiage is to enter the auto, we say eyes to the horizon, entering auto now, all the way down, roll off and catch. And we kind of say it at the same pace that you're doing it, all the way down, roll off and catch. And then instead of going straight into that, we get them to look at the trim strings first. We say trim, and this also delays getting eyes inside. Trim, make sure that's good. Now RPM, airspeed outside, and if they've got everything good, then we don't keep going on with that. And it's just got that initial, is everything set? Leave it alone. Stop touching the collective. just slide that thing in, But yeah, it's. Well, I'm glad the video was helpful anyway.
Well, if I can add to that. If I can add to that too, for those of us that chair fly, having that routine of the script and the action and how you're doing it when you're sitting in your room, using the vacuum cleaner like your buddy was in that video, like you mentioned, it was super funny. I don't know how he didn't really know how to react to that. He was just like, okay, funny. But that I thought it was hilarious. But when you're chair flying, if you're running through that process, your memorization aids in your head, it really helps dramatically, I think, especially when you go to put it in action. For sure. Clay has he gave us his question, which is good because this is a reminder. You were talking about, Richard, before we were cut off. I think your last quote was what the correct thing to do is pull full carb heat, and we were talking about the carb heat assist. But he said before the conversation cut off, Richard, you were talking about the carb heat assist when picking up into a hover. We're across the board teaching not to take hands off the collective to reapply carb heat when at a hover. But at what point would you recommend reapplying the carb heat, especially at low altitude, at low operating weight where carb heat is more susceptible? Apply collective friction and apply carb heat 100 feet AGL when sufficiently clear of any risk obstacles? Question mark. Did you get on?
Yeah, it is. It is a very sticky grey area as to when you actually. My view is, look, if you pull full carb heat prior to takeoff, you should end up in the hover with the needle out of the yellow. So there shouldn't really be any reason to take your hand off and reselect. And then my view has always been is that subject to that, then you would do it in the cruise. You certainly wouldn't do it in the climb out because that's critical, but you would do it in the cruise. I would also say, and this again is, a lot of people like it, a lot of people don't like it. It's one of those things where if you've got somebody in the cockpit and you say to them, look, can you put your hand on the carb heat, please? And you watch them put their hand on the carb heat. And then, can you pull it for me up, please? Then that's not, I would say, totally forbidden. As long as you understand that the person has got the right control in their hand before the application, then that is safer than you taking your hand off the collective lever. It's a balance, isn't it, of risk in the end. So I would suggest that. Otherwise, if I'm by myself, usually I'm out of the yellow, so it's in the cruise.
Fantastic.
There's Clay.
Clay.
Perfect. Thank you for the response to that. Yeah, I'm on a ramp right now with the Forest Service doing firefighting contract. So they're starting all kinds of aircraft. So it was pretty noisy. But the reason I asked the question is on numerous instructional flights, we would pick up and taxi out. And by the time we're ready for takeoff, I would look at the air temp gauge for the carburetor, and it would still be in the yellow, even though we fully applied carb heat before we picked up. So I don't know if that's a byproduct of, the student making numerous altitude variations as they're taxiing, but I was looking for a clear, definitive thing to tell students when they go to solo where they can't ask me to apply the carb heat for them.
Yeah, well, if it's a chap or chapess or whatever, going solo, whoever, then full carb heat in the hover and definitely not take their hand off the collective lever, go into the climb, because remember, in the climb, the butterfly valve is going in the correct direction, and then once in